Now, put it back in your plate about the same place you put it last time, and let's watch what happens. Pretty cool. Did you see what happened? Let's do it again. Let's get a little more soap and try it again. See what happens the longer you hold it down there. Keep trying until you get all of your colors to dance around the plate. So let's talk about our observations. When we did our experiment, we put the milk in, we put our food coloring drops, and the first thing we did was take a cotton swab with no soap and put it in the middle. What did you notice? I noticed that some of the color was pushed away, and it looked like the milk maybe was just moving it a little bit. But then what happened when we used a cotton swab that was dipped in soap? When I put it in that time, that's when the colors really started to dance. So that tells me that there's something about the soap and the way the soap interacts with the milk and the colors on the plate that cause the colors to dance. So let's talk more about that. So the cool thing about soap is that it's made up of two very different ends on each soap molecule. And there are hundreds of thousands of millions of soap molecules in each container of soap. One end of the soap molecule is called hydrophilic. Hydro meaning water, philic meaning loving. So that part of the soap molecule loves being in water. And do you remember what milk is mostly made out of? Water. So that part of the soap molecule loves being in milk. The other part of the soap molecule, however, is called hydrophobic. Hydro meaning water, phobic meaning fear of. So that part of the soap wants nothing to do with the water. So when we have this plate, we have milk, we have soap. Half the soap wants to be in the water, half the soap wants to get away from it. Where does it have to go? Well, let's talk about milk again and what's in milk. So we said that milk is made mostly of water, fat, carbohydrates or sugars, proteins, vitamins, and minerals. So when the soap encounters the milk, half of that soap molecule loves being in the water, but the other half of the soap molecule, the part that's hydrophobic, needs to have somewhere to hide. And it turns out that its favorite place to hide is in the fat of the milk. Not only is it hydrophobic, meaning afraid of water, but it's lipophilic, meaning lipid-loving. And if you remember from our introduction, lipid is just a fancy scientific name for fat. So when we took our cotton swab, dipped it in soap, the half of the soap molecule that wants to get out of the water pushes all of that food coloring out of the way until it finds a piece of fat from the milk to hide in. So here's a couple questions for you. What do you think happens when every soap molecule has found a fat molecule to hide in? Or what do you think happens if you use milk that doesn't have any fat, like skim milk? Or milk that has whole fat, a lot of fat in it? What do you think happens if you use almond milk or another non-dairy milk? Try those experiments at home and let me know what your results are. Make sure to tag us on social media at ThinkCurio or send us an email at hello@thinkcurio.com. Thanks for joining me today.